Hi everyone, this video is on exercise 9F question 8. This is an interesting exercise, or a question in this exercise which is similar to question number 7 and 6 that we had in the last video. So this is again more about differentiating these trigonometric functions directly rather than using a standard results, because here it's about proving. So this is a standard result that the derivative of r cos x is minus 1 over root 1 minus x squared. But in this case, we want to show that why the derivative of r cos x is minus 1 over root 1 minus x squared, because it seems like very different, because normally when we have a trigonometric function, the derivative also has trigonometric functions. But in this case, as you can see, we don't have a explicit trigonometric function. So let's see. For part one, we can start by saying that let y be equal to r cos x. So that's the first step. It's a nice trick that we use in questions that we have inverse trigonometric functions. Okay, now at this point, what we can do is we can now basically find the cos of both sides. So apply the cos function to both sides, because that allows us to cancel out this r cos. So we will have cos y is equal to simply x. And now let's find the x dy, because the x is written in terms of y. So the x dy is equal to cos y differentiates to minus sine y. And hopefully you remember from the previous questions that one we can now do in order to find dy dx. Basically, dy dx is equal to 1 over dx dy, as long as the function is nice. And you don't need to worry about the meaning of what does it mean when we say the function is nice. So yeah, in this case, dy dx is equal to minus 1 over sine y. Okay, so now we know dy dx, and remember that initially we had y is equal to r cos x, and we found dy dx. Dy dx is equal to minus 1 over sine y. But it's not quite what the question is asking us to show, because the question is asking us to show the derivative is minus 1 over 1 minus x squared under the square root. So in this case, we need to do some more adjustments. Let's go back here when we had cos y is equal to x. So remember, this was one of the initial steps. And let's see what we can do with this one. So if we square both sides, because what I have in my mind is the identity, because I need to find a way that connects cos y is equal to x, somehow connects to sine y. And probably the most straightforward way that allows us to connect them is by using the identity sine squared y plus cos squared y is equal to 1. So always in questions like this, the best way that you can connect two trigonometric functions is by using the identities that include both of those functions. So in this case, I need to square both sides to get cos squared y is equal to x squared. And I can now rewrite, because remember, in our function, we have sine y in our denominator. So I want to connect these two together. In order to do that, I need to rewrite this in terms of sine, because cos squared y, this could be rearranged if you want to write this in terms of sine y. Cos squared y is equal to 1 minus sine squared y. So 1 minus sine squared y is equal to x squared. And now we are getting very close, because here we have sine y. So let's rearrange this one more time. Sine squared y is equal to 1 minus x squared. And finally, let's take the square root. So if you take the square root of both sides, you're gonna get sine y is equal to square root of 1 minus x squared. And this is exactly what the okay, so let me substitute this into here and then show you the question again. So now instead of sine y, we can write square root of 1 minus x squared, and this is exactly the same form that we were asked to show, minus 1 over square root of 1 minus x squared. Okay, now let's do part B. Part B is showing the derivative of arc tan x is 1 over 1 plus x squared. So it's very similar. The only difference is that this time we have tan, so we need to use a different identity, but the structure is very similar. So again, like the previous question, we can start by saying that let y be arc tan x, and then apply the tan function, so we get tan y is equal to x. And let's find dx dy. So tan y differentiates to sec squared y from standard results, but in the previous video I showed this directly. I think it was in the previous video. It's just a quotient rule because in case you're curious, because tan x is equal to sine x divided by cos x. So if you just apply the quotient rule, you will get sec squared y at the end. So that's the reason tan y is equal to sec squared y. dy dx is tan sec squared. Anyway, back to this question. So dx dy is sec squared y. Okay. Then let's find the reciprocal of the derivative because we want to have dy dx, not dx dy. So it's going to be 1 over sec squared y. Now, the same as the previous question, let's go back to this form. So we had tan y is equal to x, and let's see what we can do. So the key here again is that you need to see how you can connect tan y to sec squared y, and we can simply do that by using this important identity, which is 1 plus tan squared x is equal to sec squared x. Right. Again, like the previous question, we square both sides. Tan squared y is equal to x squared. And here, you just need to realize that if we add 1 to both sides, let's just add 1 to both sides, because if you look at here, we want to get from tan squared to sec squared, and in order to get that, we need to add 1 to a tan. So let's add 1 to both sides and see what happens. 1 plus tan squared y is equal to 1 plus x squared, because it's an equation, right? We are allowed to apply any operation as long as we apply to both sides of the equation. Now here the interesting thing is that the left hand side, which is 1 plus tan squared y, is exactly the same as sec squared. Sec squared, in this case, is sec squared y, because everything is written in terms of y. So we have sec squared y is equal to 1 plus x squared, and this allows us to rewrite sec squared y in our derivative as 1 plus x squared. And this is exactly what we wanted to show. So the derivative of arc tan x is 1 over 1 plus x squared. So a quick note before I finish the video is that it's honestly your choice. So you can either spend a bit of time and memorize these standard results, or just try to derive them directly in your exams. My suggestion is it's probably a good idea to spend some time memorizing them, and obviously if you keep applying them in different questions, you won't forget them. So it's good to memorize them, just because that can save you a bit of time in the exam, rather than just deriving them. But when it comes to a case that you're unsure, let's say it's you're in the exam and you're unsure, so then obviously the best way is just to derive them. But yeah, as the default, I would personally memorize these and then use them in the exam. Okay, that's it for this video, and thank you for watching.